Okay, in the problem 3 in the code book it is 0.85. Okay, this value here it is 0.85, that is the design strength for AP reinforcement ratio of 0.3, but when writing I have written it as 0.35, but it is 0.85. Make a note of it and correct it. Okay, but final answer here it is correct, and finalized answer for the FPU also it is correct. Next we shall proceed for the problem number 3, flexure. Okay, a pre-tension beam PSC of I section with 160 by 70 mm flange dimension with thickness of web 50 mm and overall depth of I section is 320 mm. The beam is pre-stressed with 4 high strength steel wires of 7 mm at an effective depth of 265, and FCK FP is specified. You have to determine what is the ultimate flexural strength. Okay, first write the sketch as usual. Width of the flange, depth of the flange is specified, overall depth is specified, effective depth is also specified. I have told you, whenever a flanged section is given, it is very much necessary that you will assume first. An assumption has to be made in order to determine the actual depth of the neutral axis. Okay, before that, here in the data it is specified that there are 4 numbers of the 7 mm dia of the bars. First we shall calculate what is the area of the reinforcement. A is equal to 4 into pi d square by 4. You will get it as 154 mm square. Then after making an assumption, compute what is the reinforcement ratio. Read what is the XU by D value. Here your reinforcement ratio is 0.116. Okay, go back to the 456, 0.116 here. You do not have any direct value, you have to do the interpolation. 0.116 is lying in between 0.10 and 0.15 here. Okay, so you have to write an you have to write the value in between these two, so that you can do the interpolation like this. 0.11 you have got it, and the corresponding XU by D also you have to write it, that is 0.217, and this one 0.217. here it is for pre-tensioning case. In the data it is been specified that it is a pre-tensioned beam, and it is 0.326. in between these two values you have to find out what is its corresponding value. Okay, you will get it as 0.25. Find out what is XU, and again compare with the assumption. So earlier you had made the assumption as it is lying in between the neutral axis is lying in the flange portion. Since you have got x66, compare that with the depth of the flange. Depth of the flange is 70 mm. 66 is lesser than 70 mm. Therefore, assumption what you have made is correct. Neutral axis lies in flange. So, if the assumption is correct, if the neutral axis is lying in the flange portion, then you have to compute the moment of resistance by utilizing the equation for the rectangular section as specified in the IS 1343. This equation, okay, this equation it is specified. It is been exclusively used to calculate what is the moment of resistance for the rectangular cross section. Okay. Next we shall come back to the problem, and using the table number 11, find out what is the design strength value, find out what is FPU, and find out what is the moment of resistance. That's it.